Hey guys, so here you see this molecule. If I take a look here, what you see is two carbons, the one in black, hydrogen in white, and the chlorine in orange. So this is actually 1,2-dichloroethane. And today you'll be learning from me how to draw the Newman projection. So every time we draw the Newman projection, we have to ask ourselves and look through the carbon-carbon bonds. In this case, the black balls here, right? So now this is the molecule, 3D. I can rotate and you see, because they're all sp3 hybridized orbital. So free rotation. And suppose you put these two carbons together. Right now, from your view, you only see one of them because it's being blocked by the back carbon, right? And you see that for the top here, all the front balls, the atoms here are blocking the one at the back. So we call this an eclipse. Eclipsed conformer. And how do you represent this drawing then? Right, so you take a pen and you go, always draw these first. A circle, 3 lines, and the angle between these 3 lines must be exact 120. This part I'm pointing to represent the front carbon, and the back one, of course, is hidden. And because we know that it is eclipsed conformer, we will draw a slight shorter bond by the side. You see a slight one? By the side, and here by the side, by the side. This means these bonds here, the shorter one, are the one at the back, but it's being blocked. Now, what I'm going to do now is to insert the atoms at the front carbon. What I see are the hydrogen, the hydrogen, and on the left is a chlorine. At the back, do you see that this part is being blocked by another hydrogen? So here, I will also put the H. The side one here is being blocked by a chlorine. So I'll put a Cl. And the one on the left, the Cl at the front, is blocking the hydrogen. So I'll put the H at the back. So this is how it looks like for the eclipsed conformer of 1,2-dichloroethane. Some of you might ask, this can shift, right? What happens when I block chlorine using chlorine? And I get this. Can you see the 3D? When the chlorine atoms are closer together than just now. So for this case, it will be a different drawing. It will look like, once again, the circle, 3 lines for the front bonds, and because it's eclipsed, we draw a shorter one by the side of each of these longer bonds. Now, let's analyze. The top atom here is a hydrogen blocking a hydrogen. H and H. The side one here, chlorine blocking chlorine. So I put Cl and Cl. And the last one, hydrogen blocking hydrogen. So I put down here as H and H. Now, both of these are eclipsed, but you notice something very different. That is, in the previous case, when the chlorine are not overlapping each other, when they are further apart, the electron cloud are not repelling so much because of the distance. So in this case, this is of a lower energy, than this case. Because here you see the chlorine, they're so close, they're just repelling each other. It is so bad. Electron cloud, repelling each other. So high energy, low energy, but both are consider eclipse.